All right, for our second video, we're going to look at subtraction of rational expressions. So, in our first video, we looked at addition, and we noticed that we always need to find a common denominator first, then we add or subtract the numerators. It's going to be the same with subtraction. We always need a common denominator first, add or subtract the numerators, then simplify at the end. So let's look at our first example regarding subtraction. We've got 18v to the fourth and 18v to the fourth as our denominators, so we have a common denominator already built in. Now we just look at our numerators and we subtract them. So we have 4u minus 6v, that was this numerator, subtract this whole numerator of u minus 4v. So it's going to look something like this as our new rational expression with our common denominator of 18v to the fourth. This is not a simplified numerator yet, though. We've got 4u minus 6v minus this whole thing, u minus 4v. This is what it meant before by distributing this negative. Minus a positive u means minus u. When you minus a negative 4v, it actually means adding 4v. So this is what our rational expression should actually look like. 4u minus 6v minus u, or just 1u, plus 4v. That's going to be our numerator over 18v to the fourth. Now we just simply match like terms. There we go. And there we go. Now we have our like terms, we just put everything together in our numerator. 4u minus 1u makes 3u. Negative 6v plus 4v makes negative 2v, or minus 2v. It's still all over 18v to the fourth. Now we're not done, we still have to simplify if we can, but if we look at 3u minus 2v, there's nothing we can take out of there. We cannot factor this out. And this 18v to the fourth cannot cancel with this whole thing, 3u minus 2v. This is all one factor. This is a few factors. I mean, it's one term, but it has a few factors in it. So this one will not cancel with this one. This is our final answer. Let's look at another example then. We have 6b over 2a minus 2a over 4ab squared. Like before with our addition problems, let's look at all of our denominators. 2a is 2 times a. 4ab squared makes 2 squared, because 4 is 2 squared, 2 times 2, times a, there's our a, times b squared. So we have these three bases, 2a and b. This one just has 2 and a. When we look then at our common denominator, we have to have all three bases. 2 is there, a is there, we've already seen 2, we've already seen a, we need b in there as well, b is right there. Now like before, we need the biggest power of each one. A and a are just to the power of 1, so that's already taken care of. This 2 is to the first power, this 2 is to the second power, so we need the second power, not the first. So we need 2 to the second power here. And b, there's only one of them, is to the second power. So we need this b to the second power. This is the factored form of our common denominator. If we were to spell it all out, it would be 4ab squared. Now notice, luckily, 4ab squared is already this denominator. This one is already done for us. It already is the common denominator. This one, this 2a, is missing some things. It has a 2, and it has an a right here, 2 and a. So it's missing one more 2, so we need to multiply a 2 in there. It's also missing a b squared, so we need to multiply a b squared in there. This means on top and bottom we're multiplying by 2b squared. When we do that, it looks something like this. 2 times 6 makes 12, b squared times b makes b to the third. And I'm going to leave our denominator as the factored form, 2 squared times a times b squared. This whole rational expression is our new one minus We'll leave that old second one because that one doesn't need to change. Just 2a over 2 squared times a times b squared. Now remember, these two are the same or common denominators. They mean 4ab squared. Now that we have a common denominator, we just subtract our numerators. So it's going to look like this. 12b cubed minus 2a, so it's just this piece minus this piece, all over 2 squared times a times b squared. Now we want to look and see if our numerator can be factored. And yes, it can. We can take 2 out of each of those, and it becomes 2 times 6b cubed minus just a. 2 times 6 makes 12. 2 times a will make this 2a. Now that we know we can factor those out of each other, or out of that piece, we notice 2 and 2. This is no longer 2 squared, it's just 2 to the 1. We took 1, 2 out of the top and the bottom. This helps us just to simplify everything down. Now, instead of being 12b cubed over, or 12b cubed minus 2a all over 4ab squared, we knew that we could divide 2 out of everything, and so our final simplified unfactored form is going to be 6b cubed minus a all over 2ab squared. We cannot factor anything else out of these ones, which means we can't simplify it any farther, so this is going to be the final answer. All right, we have another example here. 6x over 5 minus 6x over 4x cubed. We have common numerators, but that doesn't matter. We need the denominators. This one factored out is just 5. 5 is our prime factor there. 4x cubed actually is 2 squared times x to the third power. So these are our bases. We have a 5, we have a 2, we have an x. And if we put them each to the highest power that we have, it's still 5 times 2 squared times x cubed equals 20x cubed. This is going to be our common denominator. This is what it is as a factored form. So we need to change both of these so that they will meet this factor. Now looking at our left side, what are we missing? We have the 5, but we're missing 2 squared and x cubed. So we're going to multiply it by 4x cubed on the top and on the bottom. 4x cubed. Now looking at our second one, the 6x over 4x cubed. 4x cubed is the 2 squared times x cubed, so the only thing it's missing is this 5. So we're going to multiply top and bottom by 5. That'll help change both of our rational expressions so they have a common denominator. This first one, 4x cubed times 6x, becomes 24x to the fourth. And it's still all over our common denominator of 5 times 2 squared times x cubed. Minus our second rational expression, 6x times 5 makes 30x all over 5 times 2 squared times x cubed. Now, combining these, because we have common denominators, 24x to the fourth minus 30x just becomes 24x to the fourth minus 30x. And it's all over 5 times 2 squared times x cubed. So using this, we want to simplify if we can. To do that, we look at our numerator and say, what can we factor out of the top? Also, as we're factoring, we want to try to take out only factors that can cancel on bottom. So even though 24 and 30, we can take 6 out of both of those. That is the highest one we can take out, but we don't have 6 down here. So the only things we really have, we can take x out of both of these, and we can take 2 out of both of these. So let's factor it out as 2x on the outside, which leaves us with 12x cubed minus 15 on the inside. Now our denominator stays as this 5 times 2 squared times x cubed. Now, we still have this 2x on top and bottom as its own factor. We'll take 2 out, and that means we take one of these 2's out, so it's just 2 to the 1 now. We'll also take one of our x's out. cancels this out and makes it to the second power. Now we've canceled out these factors, so really our numerator is just going to be that 12x cubed minus 15. On bottom we've got 5 times 2 to the first, which is 10, times x squared. So our bottom's just going to be 10x squared. This is now our fully factored and simplified final answer. Even though we can take 3 out of both of these, that doesn't really help us that much because 3 doesn't cancel here. So this is going to be our final answer. That's all we need. We've got another example here. 3a over 5 minus a plus 3 over 3a plus 6. Again, factor both denominators. Oops. All the way back to the beginning. There we go. Delete that box. This one just becomes 5. 3a plus 6. We can factor it out as 3 times a plus 2. So these are our two, or should I say our 3 bases, our 3 factors, 1, 2, and 3. So our common denominator will have all 3 of them, 5 times 3 times a plus 2, which means if we were to combine it all together, simplify it out, it would become 15a plus 30. But we're going to use this factored form when we're trying to find our new rational expressions. Looking first at this first one, it already has a 5, which means we're missing a 3 and an a plus 2. So we're going to multiply it by 3 and an a plus 2. On top, we're also going to have a 3a plus 2 that we're multiplying by. This one over here, we have the 3, we have the a plus 2. What are we missing? Just this 5. So we're going to multiply it by, oops, that looks like a 6. We're going to multiply it by 5 on top and on bottom. So that'll help us create our new rational expressions. 3 times 3a is 9a. 9a times a plus 2 becomes 9a squared plus 18a. On the bottom, we keep our common denominator of 5 times 3 times a plus 2. Minus is still in the middle here. A plus 3, this is all one factor being multiplied by 5, so we have to distribute it. It becomes 5a plus 15. And our common denominator stays as 5 times 3 times a plus 2. Now, we take our numerators and just combine them together. So it's 9a squared plus 18a. This gets distributed, so I'm going to get rid of it and just do minus 5a. And I'm going to get rid of this. It was a plus, and now becomes a minus 15. So, as we combine our like terms, 9a squared is the only a squared that there is. Positive 18a and negative 5a, those will go together. And this minus 15 is the only constant there is. So our numerator becomes 9a squared plus 13a minus 15. 18a minus 5a makes 13a, and all of our other terms stay the same. It's still all over 5 times 3 times a plus 2. That was our common denominator. Now, 9a squared plus 13a minus 15. We cannot take a greatest common factor out of that. We also cannot take an AC method and factor this at all. So this is our fully factored. This is our final numerator we can do. We can't simplify it at all. So we can just simplify the bottom. 5 times 3 is 15. 15 times a plus 2 becomes 15a plus 30. So again, either one of these is an acceptable final answer. If you want to leave the bottom in factored form, that's okay. Or if you like to spell it all out, 15a plus 30, that's all right too. Either one. So those are going to be our final answers for the subtracting the rational expressions. And that'll wrap it up for our last video.